just so my students can pass. You want number 2? Wait, we did? Okay.
Yeah, we did this one.
All right, so number 2? Okay. So usually a good thing to do is to write out your null hypothesis so we know what's going on. So if I got it here. Okay, so the null is going to be equal now. We're talking about a ratio, right? Like proportion. We're thinking that equals 3/5, whereas the alternative is that rho does not equal 3/5. Is that right? Yeah. Okay, so now we have a test statistic, 0.78, and we have an alpha. So we know that when we want to take our test statistic, we're going to put in our alpha, you know, like this, yeah? And this part right here is going to be 0.025, and over here as well. And that would be alpha divided by 2, right? And this is alpha is equal to 0.05. I don't even know why I'm doing that. Oh, yeah. Am I doing number 2? Is that correct?
Yeah.
Okay, now, where does the test... Now, this would be critical values, right? But we don't know what they are. We could find them out now, though, because if you have 0.025 in the tail, what do you have here for critical values? Is it 1.64? I don't know. Take a look. Is it? Oh, you could tell on your table. On the normal table, look for alpha in the guts, or looking for 0.025. 0.025 in the guts. How about you tell me the critical value? Oh, no, that's a test statistic. I'm talking about critical values. That's would be the number associated with the alpha.
So it's negative 1.96.
Okay, so these are 9.6. All right. Now, look at the test statistic right off the bat. Where is that hitting? Yeah, I mean, the 0.78 is the test statistic. So this is 0, right? And now it's going to be 0.78. So, but that's a test, that's the z-score, right? So 0.78, remember here's 1.9, right? 6. So maybe right here is the z-test of being 0.78. Yeah, that's hitting in the accept range. Okay, now, in order to find the power, not the power, the p-value, I'm going to have to find the area from here on back. Now, I already know this is going to be bigger, right? So I'm already in the do not reject. Correct? Is that right? So now, I'm telling you, now I want to know the area from here all the way this way. So if you want to look in the guts for 0.78, it might tell you all the way this way. You know. That's okay, because we'll subtract 1. So did you come up with a... Now I'm giving you, you know, the z-score is 0.78, and I want to know what the probability on the curve is. Now it should be giving you the area from here up, right? Yes.
7823.
So what is it?
1 minus 0.7823.
Well, yes, it's 7. What is it area here back? It should be on your table. It's the same as this test score? The area?
0.78.
You're looking for 0.78 on the rim, on the edges, not the guts. It's a z-score. Look in their margin. Your margin? Is that the area from here on back? It's kind of confusing because the z-score is 0.78. So it is 0.78 too?
0.7, yeah.
Oh, that's weird.
3.
Okay, subtract that from 1.
0.2177.
Okay. And then here's 2177. And here's a 2177. Did we fail to reject?
There's a trick with this one, I remember.
Right, you got to double it. Double it. Look at that. Now, do we accept or fail to reject? Reject or fail to reject? So letter C? It's not. You get it? Or no? You look like you don't get it. Because your nose gets redder. That's not from that. That's from drinking. I'm just kidding. The power, the p-value is the area of the curve from here to the right. But because we took this area and subtracted 1, right? But because it's two-tailed, we have to double the p-value. And that's why we came up with this answer, but we're supposed to double it because it was a two-tail. And we already know we're in the do not reject area, right? Because this is a test score, Z star. The critical value is 1.96, so if we didn't even calculate the p-value, we know that this is hitting between the correct critical values. That is the acceptance zone. You answered them all? Did you want me to cover new material or what? Do you want to talk about regression analysis? Is it okay? You understand it? Is that easy? No more questions? Oh, the bird problems? I mean, the homework? Only a nice guy like me allows that. You got like, oh, the light goes on. I think I understand. Not completely, but kind of. It starts coming in from behind like a dream. You know, it's not right in your face, but then it starts popping in. I like that feeling. You know, you wake up, I understand it now. It must have been that last vape. It really helped. Just kidding. No, I don't know. It's like, sometimes you have to just jog the neurons around. But you know, that's what it is. It's just putting your time in, right? How can you pass this class without doing homework? It just doesn't make sense. And that's why I marked up the homework so high at 65% of your grade. I'm trying to motivate everybody to do homework. It makes my life easier when you do it. Yeah, like the last day of the semester, yeah. You were getting depressed. You were like, oh no, I can't do it. It's not that bad, but it's just a way of looking at things, right? When I took my insurance broker's license, right, and so I started reading about how to get your insurance license, and I found out that a lot of people are taking that test because you can't sell it without taking an insurance test, a state test, and then in that you have basically 4 lines, they call it lines. So you have your personal lines, which would be like your auto insurance or motorcycle insurance. You have homeowners, you know, if you buy a house, or if you rent a house, you can have renter's insurance, you know, those sort of things you can sell. And then you have another one that's for commercial. That's another license. So it's commercial license, and that's when, you know, they're bringing, you know, it's covering ocean liners that are crossing with merchandise. They got insurance too. So you learn about that, and you learn about every little business has insurance. I mean, that was the thing. Everybody has insurance. So, well, my idea was I was selling real estate, so I might as well sell them the homeowner's policy. So that was my idea, like one-stop shopping. I'll just sell them the insurance and this thing. So, but I started reading on this insurance stuff, and it was so different than what I'm, you know, to kind of put your mind in an insurance sort of manner. It's about mitigating risk. That's really what it is. It's about and a lot of statistics. It's it's called the law of large numbers, which is what it means that you can best prepare for losses the bigger your numbers are. You have more information to deal with, so you can be better predictor. It's a bigger sample. And so it took me a while because I was just reading it on my own. I didn't take a class. And they have a way of looking at things, and they use certain forms that it took me a while to wrap my head around it. But once you see what they're doing, but it was a little bit weird like that, because I thought it'd be something like real estate, but it's not really. Well, it's up to you. If you have no more questions, then I mean, we were going to talk about, I don't think we were ever going to get there, but the other question is, let me just give you a quick thing here. So it turns out that if you want to do, there's a lot of money in this, is linear regression. we can put anything we want here in terms of time, and then we can do some, I don't know, sales numbers. And so this is divided up over a certain amount of time. And this is based on your past business and the history of that past business. So you know how much you sold in each of these time periods, right? Let's say, for example. Okay, now this is really important because I tell students, you know, when they go to economics class, they have a cost function and then they have like a supply and demand, right? And where they meet is the optimal units to be made and the optimal price to sell them at, right? Now, the reason I'm doing that is that when you're in school, usually we give you an equation telling you what these are, right? And then you can set them equal to each other to find that intersection, correct? But normally when you're out and get a job in industry, nobody's going to hand you the cost function. So you have to try to like figure it out from the data. Okay, so one way to do it is we use calculus basically, and we fit in this case, a linear thing. So we fit in a line the best fit, and mathematically the best fit was going to be like, come on, it's not working. Okay, imagine these are rubber bands of equal elasticity. Okay, and then optimizing this by using calculus, we can actually set that so that it balances out among all the, this is called a regression. And the reason I call it a regression was the guy running experiments was running heights of parents versus their children. And whatever test he ran, it looked like they were getting smaller. They call it a regression. So it turns out, right, that this thing can be modeled like y equals mx plus b, right? So, and that would be like the true line that goes through there, right? But we don't know the true line. But we have a y hat just like we have p hat. And that's made up with this, you know, it'll be like an m hat x plus some constant. This is a c. Okay, so what do we check for statistics? For statistics, we're going to make claims on the slope. So this is going to say that m is equal to 0. Well, a 0 slope means the line's flat. Okay, and the alternative is that it isn't, or whatever you want. Okay, what that means is that it's significantly different than 0. Okay, so if I have sales and I have whatever other times or whatever, if this sucker was flat, it's telling me there's no relationship between the sales and time going by. You understand? So all we're doing in statistics is testing the slope. And if the slope, you know, and it turns out that this fitting of the curve also has a normal distribution. In other words, if I drew them sideways like this, each one has like a bell curve this way, you see it? And actually the bell curve's a lot tighter here, but what would happen that if you start, now you can use the same, if that fits right, then as a statistician, you can extend this line and start making forecasts about the next year's sales. That's the importance of a regression. I used to do it for, in graduate school for banks. Banks would have different, they want to know what's the optimal point, so we'd have a couple of equations, a couple of scattered plots and run a regression through it and see if they can do it. And now, so you can see that even on this case where you had the you know, right, you would have the same exact thing, critical values, p values, whatever. But we're answering this is m, not mu. This looks like mu, huh? Yeah. You understand what I'm saying? So it's a pretty interesting thing to know. So there's no reason to stop here because you can be in multivariate space like this. I'll make that solid. Let's say make that solid. See if this is a z. This is the y that I pushed over to here, and here's the x. I changed the battery up. Okay, so we have this, this, and this. So now, if I have a dot in space, can you tell me what the coordinate is for that dot? What is it?
X, Y, Z.
Yep. So you would have like the little x1, comma y1, comma z1, right? If it were like the first two, let's say this is the little x1, right? And or we'll call it y1. Okay, and this is the little x1 right here. You see it? Way we would normally graph it, we go like this, and this would be our x comma y 1 1. See it? But now we have a z. We have to go up into space this amount. Actually, we would be over this way, right? And then we go up this amount of z. See? Where my fist is, I have a coordinate system there to point out where it is. If I call this the y, and that's the x, and this is z. So this has a position. So suppose now that I have a bunch of positions, right? Just like I did here, right? But now I'm 3D. Okay? Somebody say okay. So guess what I fit in between all these dots? What would you say? So I got a bunch of dots in space. So what did I do here? I fit a line. And what do you think I'm going to do here? Yes, good. Instead of just a line, I'll put a sheet of paper through it, like a plane. So watch. I'm going to fit a plane in here. Not an airplane. A sheet of paper. And that's going to have a slope this way and a slope this way. So we have to use what's called